We're going to take a look at difference of two squares factoring, and by this stage you would have already encountered GCF factoring, or greatest common factor factoring. Difference of two squares is just another technique, and we'll go on to learn more techniques. And before we get into the rules of this, I'm going to show you a little example. When we were learning multiplying polynomials, we would take a thing like this and we would say, let's do double distribution. Let's distribute the x, and then let's distribute the 5. And when we do that, we get a bunch of terms, and almost always those inner two terms, they end up adding together. In this case, they add together to be 0. So this piece ends up equaling x squared minus 25 when I multiply. And if I had to kind of abbreviate it, this times this equals that. Well, when we were multiplying, we were kind of thinking in that direction. When we're factoring, we're always thinking in the reverse direction. So what we're going to do today is we're going to say, hey, if we find something that looks like this, can we turn it into something that looks like that? Factoring is always the reverse of multiplying. The next thing you'll need to know is that you need to understand or have in your head all the squared terms. And you'll see why I'm doing this in a moment, but 1 squared is 1, 2 squared is 4, 7 squared is 49, 9 squared is 81. So basically what we're saying is anything squared, you should know what that is, because that's what's going to help you out in this thing called difference of two squares factoring. That should be a big hint right there that you need to know your squares. If you don't have these on the top of your head, then you should literally write a list that looks exactly like that and have that available for you when you're doing these problems. And if you do that, these are going to go into your head anyway. So here's this very first problem, and it should look familiar because we were just talking about that. This is binomial form. This is factored form. So how do we take this binomial and turn it into this factored form? It's a pretty simple checklist in your head. You're going to ask yourself 3 questions. Are there 2 terms? Yes, there are. 1, 2. Are they subtracted? Yes, they are. And can I square root both terms? Can I square root an x squared? Yep, it's an x. Can I square root a 25? Yep, it's a 5. That's why I think it's important that you have this list either in your head or available. When I see a 25, I know its square root is a 5. When I see a 9, I know its square root is a 3. If I can say yes to all 3 of those questions, then I just literally take that and I write it in this form. It's the square root of the first term, the square root of the last term, and you have a plus and a minus. This is turning into that if I go factored form. And if you wonder if that's correct, then like always with anything factored, you can check your final answer by doing the distribution. And in this case, I would get x squared minus 5x plus 5x minus 25. Those two would be like terms, so they would add together. In this case, they add to 0, and I get x squared minus 25, which is where I started, which makes me happy. So let's take a look at this next problem, and we're going to always have this checklist going on in our head. Are there 2 terms? Yep. Are they subtracted? Yep. Can I square root both terms? Yep. And in fact, what you might want to do is right underneath here, just write down the square root of x squared, write down the square root of 49. And as long as you've said yes to those 3 questions, you just put it in this form, x plus 7, x minus 7, and you have your final answer. Remember, if you did the and write it out, you would lead back to that, or you've done something wrong. Let's take a look at this next one. Oh, I like that because the square root of 16 is 4, but there's danger here. I can't say yes to all three of these questions. Are there two terms? Yep. Is it subtracted? Ooh, no. So if it's not, then what I would say is, in this case, it's not factorable. So if it's not factorable, I can't change the form into factored form, so I just rewrite it as x squared plus 16. Let's get a little spice here. 4x squared minus 9. Two terms. Subtracted. Can I square root both terms? Well, the answer is yes, but this one's a little bit trickier. The square root of a 9 is a 3. 4x squared has a square root of 2x. Now, how do I know that 2x is the square root of 4x squared? If I wonder, take 2x and multiply by 2x. 2 times 2 is 4. X to the first times x to the first is x to the second. I've said yes to all three of these, which means now I can just simply write out this form. And I'll show you that if I do the distribution to check myself, it does work out. There's the proof. I did my like terms. In this case, added to 0, 4x squared minus 9. I'm a happy guy. I deserve a donut. Okay, the last problem. Are there two terms? Yep. Are they subtracted? Yep. Can I square root both terms? I certainly can. That is a 5x. And that is an 8. Remember, I should always have this available or in my head. And so in this case, 8 squared is 64, or the square root of 64 is an 8. And so now I can go ahead and write my final answer. 5x plus 8, 5x minus 8. Take my word for it. If I were to do the I would arrive back there, and I know I have a final correct answer. And just as an FYI, if somebody else in any of these problems writes these two pieces in a different order, the subtraction term first and then the addition term, that's also going to be correct. You could prove that to yourself by just going ahead and doing that multiplication. You'll see that you end up back there. So anytime you see two terms in a problem, then ask yourself these next two questions. If you've said yes to all three of those, you can simply follow this pattern and you've rewritten the binomial into factored form.